Hello and welcome to Maths Albertua today. Today we want to see, look at the question under application of integration. They say the gradient of a curve is 2x plus 7. Alright, gradient of a curve is 2x plus 7. So look at what we write first of all. We're going to say the first thing 2x plus 7. The gradient means the y dx. So we're going to write like this. We're going to say gradient is actually 2x plus 7. So replace gradient with what? With the y dx. Alright, write it as 2x plus 7. Okay, so this is what we have now. And now, so you were given the gradient of the curve, and you are asked to find the equation of that curve. So it's the equation on application of integration actually. So you are given gradient of a curve, and you are asked to find the equation of that curve. Alright, so see what we're going to do first. The next thing we're going to do now is to multiply both sides by dx. Okay, so if you do that, look at what will happen. I want to write dy dx multiplied by dx is equal to 2x plus 7 all multiplied by dx at the left hand side here. So we're going to say dx. Alright, so here the x cancel. Let me use another color to make so the x here cancel out the x. That means that at the left hand side we're going to have what? At the left hand side we're going to have dy is equal to what? 2x plus 7 and then what? Dx. Okay, let's finish it all over here. Now the next thing to do is to integrate both sides. So just integrate both sides. That's the next thing to do. So integrate both sides. Alright? So integrate both sides. If you do that, we're going to have integral dy is equal to integral of into what? 2x plus 7 dx. Okay? Alright, so this is what we have. Now, at the left hand side here, we're integrating with respect to y, and there's no y that is seen in that place. So we can manipulate it and bring in y there. How? I'm going to say integral y raised to the power of 0 dy is equal to what? Integral. So this place here, you can actually break it down, like to make it very simple. So this part, you can say integral of 2x dx plus integral of 7 dx. Okay? Now, if you integrate y raised to the power 0 with respect to y, it means you are adding 1 to the power and dividing by the total power. So at the left hand side here, this place will give you y. See why you get y? 0 plus 1 divided by 0 plus 1. Of course, this thing will give you what? Y raised to the power 0 plus 1 is 1 divided by 0 plus 1, 1. So y raised to the power 1 is something as just y in one place. That's the same thing as y. And then divide the answer by 1, it does not change. That is why we say that what? That this left hand side here will give you what? At the left hand side here, if you integrate y raised to the power 0 with respect to y, you just get y equal. Now, if you come to this place, if you integrate here, you're going to have 2x. First of all, okay, we have 2x raised to the power 1. Let me have it like this, dx, first of all. Then when you come over here, write it as integral of 7x raised to the power 0 dx. Okay? Now, see what will happen. We're going to have y is equal to, when you integrate here, you're going to have 2x raised to the power 1 plus 1. 1 plus 1 is going to be 2. Divide the answer by, please, let me just write 2 in that place. So in algebraic integration, we just add 1 to the power, divide by the total power. So if you add 1 to this one that has been existing here before, you're going to get 2, divide by the total power here. Now move on to the next one. If you integrate over here, you're adding 1 to power 0. So 0 plus 1, you're going to get 1. Okay, so we're going to have here as 7x raised to the power 1. If you divide by 1, it does not change. Do not forget to add the constant of integration, constant C of integration. Now, we are almost done with the job. Now, you are told to do something. They gave you a point. Okay? They say you should find the equation of the curve. They say that the gradient of a curve is 2x plus 7, and the curve passes through the point. This is the coordinate of the point, 2, 0. Now, find the equation of the curve. So, we need this point in order to get the value of constant C. Okay? So when when the point 2, 0 means what? Means that the x value, it means that the x value is 2, while the y value is 0. Of course, you know that here, 2 can remove 2 here. Meaning that, see what we're having now? We're now having y is equal to s squared plus 7. Plus 7x plus c. So put in the value of x and y to find the value of constant c. Let's go. So we're going to have 0 is equal to s squared plus 7x, no, 7 bracket what? 2, and then plus the constant of integration. Okay, sorry, I omitted something here. Here is meant to be, we're replacing x with 2. So here with 2 squared. Okay, so over here we have 0 is equal to what? 2 squared is 4. 7 times 2 is 14 plus constant c. Alright, so here we're going to have 0 is equal to what? If you add this and this together, you're going to get 18 plus c. Okay, that means c, you bring out 18 to the left hand side. We're going to have negative 18 is equal to c. Now, just go back with this and fix it here, and that will be the equation of the curve they are asking you to find. This will be the equation of the curve they are asking you to find. So that means that the required equation of the curve, when the gradient is given as 2x plus 7, is going to be y is equal to what? S squared plus 7x. Then instead of plus c now, you write negative 18. Okay, so this function we have here now is a required equation of the curve when the gradient is given as 2x plus 7, and it has to pass through the points 2, 0. So this is how we use idea of integration to answer question of this type. You are given the gradient of a curve, and that gradient passes through. You are given equation of gradient of a curve with a point, and you are asked to get the equation back, equation of the curve. This is the procedure we do, and then we arrive at the answer. Thank you very much for staying to the end. Please do well to like, to share, and subscribe. Bye for now.